Hi all, welcome to video 3 of the Databricks playlist. So in last two videos, basically we have seen the bit introduction about Databricks. In first video, we have seen why it is important to learn Databricks, and in second video, we have taken, I think, good understanding of what is Databricks, what use cases can be handled using Databricks. Okay, so while learning the last video, I told you the one of the use case we can achieve using Databricks is enterprise grade data lakehouse, right? So if I show you, let me just show you that in second video we have seen that. Okay, uh, just a second. Okay, see enterprise grade data lakehouse. Okay, so in this video we will try understanding what is data lakehouse. We will spend a couple of videos understanding data lakehouse, right? How data lakehouse came into existence, right? What was the history behind that? Okay, now I think from the name only you will be able to understand data lake house. So it is combination of data lake and data warehouse. Okay, but before going to the introduction to data lake house, I would like to introduce you, give you a brief understanding on databases, data warehouses, and data lakes. Okay, so database, data warehouse, okay, and data lake. Okay, data lake. Okay, now first thing, database. I hope you must have heard or you must have worked with MySQL, PostgreSQL, SQL Server, right? These are the databases. Okay, so databases are basically made for OLTP. Okay, OLTP is transaction transaction uh, online transaction system. Basically it is OLTP system. Okay, and there is something called OLAP, right? Online analytical. Okay. So basically, what is OLTP, online transaction system, is, for example, you have some, let's say, banking application, like let's say some UI application for banking, okay, or your let's say net banking application, right, using which you are doing some transactions. Okay, so all those transactions, whatever transactional data is there, it is stored in databases. Okay, so databases are made to store transactional data. Are made to store transactional data. Okay, so transactional data, if we think of it, it is always a structured data. Okay, structured means it has, let's say, some customer ID, right? For example, you are doing some transaction, it has customer ID, then transaction ID, then transaction, let's say, amount. Okay, transaction, let's say, type. Okay, it is, let's say, you have done it using credit card or debit card, okay, or something like that. Okay, so this is structured data. Basically this is stored in the form of tables. Okay, and databases are suitable for day to day transactions. Okay, databases are suitable for day to day, just a second, day to day transactions. Okay, now um now databases are suitable for day-to-day transactions. So that means they are not made, databases are not made to store historical data. Okay, databases cannot store historical data. They are made to store only daily transactions, day-to-day transactions. Okay, if we store historical data in databases, the daily, I would say, transactional work, whatever is happening in databases, will get impacted, right? So databases are made to store day-to-day transactions, okay, online transaction system, okay, and they are not made to store historical data. Okay. Now data warehouses, it is, let's say, analytical platform. Okay, data warehouses, what we do, we store the data that is needed for analytical work. Okay, so data warehouses, we call it DWH, stores structured data. Okay, structured historical data for analytical purposes. Analytical as in, let's say you have this transactional data, right? You bring this transactional data to data warehouses, right? And you are going to do, let's say, some analysis on this data. For example, how many transactions the customer is doing in a month, right? One customer is doing in a month, right? What is the let's say total transaction amount customer is doing in a month, right? So that we call it as the data for analytics. Okay, so this data in data warehouse is cleaned, it's cleaned and organized. Okay, simple way to store the data in data warehouses is this: it should be structured and it is cleaned, structured and organized. Okay, and this data in data warehouse is best for reporting, okay, dashboards, okay, and business intelligence. Okay, and business intelligence. Okay, that is the purpose of data warehouse. So data warehouse stores the historical data which is cleaned, organized and structured. Okay, and databases only store structured data, they are not made to store historical data. Okay, both databases and data warehouses store structured data, structured as in it has some structure in the form of tables, okay, in the form of rows and columns. Okay, now there is third concept called data lake. So data lake stores structured, okay, structured, semi structured as in you have, let's say, JSONs, XMLs, okay, semi structured and unstructured data. Okay, and unstructured data. So structured as in data in the form of tables, okay, rows and columns, right? Semi structured as in, let's say, you have JSON, you have XML, etc., right? And unstructured means you have, let's say, audio, right? You have audio, video, etc. Okay, so data lakes basically they store all three types of data: structured, semi structured and unstructured. Okay, and these are, they are best for, let's say, big data, raw storage. Okay, this is raw data, this is not clean data. Okay, best for big data, raw storage, ML, machine learning, right? And let's say, and for future analysis, and for future analysis, right? So the thing is basically what happens, I'll show you the flow. We have data lake. Okay, we have data lake where, let's say, structured data, right? Structured transactional data is stored. Then there is semi structured data. Okay, there is semi structured data and there is unstructured data, right? So you store historical data. So all historical data is stored, all historical, we can say raw data, is stored in data lakes. Okay, all the raw data is stored in data lakes. Okay, now data lake has all the data. Now the flow is basically data lake can store the data from transactional systems also. So let's say you have database. Okay, you can store the data from database to data lakes. Okay, you're storing the data from database to data lake. Okay, now let me just make it little, okay, fine. And now from data lake, data is, let's say, I will just put data warehouse. I'll just give you a quick overview how data warehouses are created. So what is done basically, for a data warehouse, data is cleaned, for example, right? Cleaned, aggregated, okay, and that clean and aggregated data is stored in data warehouses, right? This data this raw data, it is cleaned, aggregated, and stored in data warehouses. Okay, so this is about databases, data lakes, and data warehouses. Now, cost wise, if we see, databases are more costly. They are costly as compared to data warehouses. Okay, data warehouses are less costly as compared to, okay, as compared to databases, right? Databases and data lakes, they are cheapest. They are cheapest storage. Okay, recent cloud storage, they are checked storage and they are very cheap. Okay, so data lakes are very cheap storage. Okay, that is about databases. Okay, data warehouses and data lakes. Okay, so generally what we do, all the data from all the sources, for example databases, okay, you have data from any other system, not only transactional but external system also, we bring the data to data lake. Okay, we clean that data, we aggregate, we do whatever transformations we have to do using pyspark or sql, and then that data we store in warehouses. Okay, now there is one more extension to warehouses, is they are also called as data marts. Data marts. So data marts are basically what? They store the, let's say, some regional data. Okay, so for example there is some regional data, region wise data mart. Okay, or there is some, let's say, for example I have accounts data, right? So what I can do, let's say I can create for saving accounts, I can have one data mart, right? Saving account. Then for loans I can have one data mart, right? Loan account. So data marts are use case specific, right? So data marts contain the data that is cleaned in data warehouses. Okay, that is about high level idea about databases, data lakes, data warehouses, and data marts. Okay, now what I wanted to tell you now, from this data lake house, right, you will be able to understand it has data lake also and data warehouse also, right? So data lake house is basically, it is the data management architecture we can call, which combines the benefits of both data lake and data warehouse. Okay, data warehouse, let me, data lake house. So simple definition of data lake house is, data lake house combines the best properties of data lake and data warehouse, right? And we have already seen the data lake house, which they call delta lake also, it is the open source. Now it is open source. Okay, databricks is contributing to open source community also, and data lake house is one of the open source tool, we can call it, that databricks has built. Okay, now we have seen data lake house combines the best properties of data lake and data warehouse. Okay, so basically what best properties it combines from data lakes and data warehouse, right? Let's see that. The first thing is, it uses, basically it uses flexibility. Okay, and flexibility, cost efficiency, and scalability, scalability feature of data lake, right? So basically data lake, as I told you, it is cheap storage, right? So flexibility means you can store structured, unstructured, and semi structured data in data lakes, right? Cost efficiency, there are very cheap storage, and scalability as in they can be scaled as in if you want more storage, it is very easy to scale data lakes, right? And second, now what properties it is using from data warehouse, it uses data management, and acid. Okay, transaction features, acid transaction features of data warehouse, right? Now what is acid transaction, we will understand in details in the maybe in the next video. But acid is basically it is atomicity, right? Consistency, isolation, and durability, right? So it helps to get the transactional feature also, which is in databases, okay? And you can store a huge amount of data also in Lakehouse, okay? So it combines the best features of data lake and data warehouse, okay? That is about, I would say, data lakehouse, a simple definition of data lakehouse. Now the thing is, what is the reason data lake houses came into existence, right? There might be some other system, right, which had got some disadvantages, right, which people were using, and that might have got some limitations. We have seen why databricks came into existence, right? In the start we had monolithic systems, then we started using the MapReduce and Hadoop framework, right? Then we had Apache Spark, and then Databricks came into existence, right? Now, what is the reason Data Lakehouse came into existence, right? So, to understand that, we will have to understand basically the history of data warehouses and data lakes. Okay, so we will first understand basically what is the history and challenges faced by data warehouses. Okay, so as we all know, data warehouses receives the data, okay, from ETL operations, right? They receive aggregated and clean data, cleaned and aggregated data, okay, and ETL operations performed on, let's say, data from many sources, data from many sources, right? So when data warehouses came into existence, at that time data lakes were not used. Whatever data was coming into data warehouses, okay, what they used to do, let's say you have, let's say, some two three sources of data, one, okay, then we have two, right, and we have three sources of data, okay, let's say source 1, source 2, source 3, right? Now all this data, there used to happen an ETL, right? ETL is what? Extract, transform, and load. Extract means what? Get the data from all these three sources first. Okay. So I'm getting all the data from all these three sources here. Okay. Then what we are doing? We are transforming data. Okay, we are like removing few nulls, right? We are doing some aggregations, right? We are checking primary keys and all that stuff, and then what we are doing, then we are loading the data to data warehouse. Okay, so if you can understand, if I have to load the data to traditional data warehouses, we don't have any flexibility. Whatever data is coming, that data should go through ETL operations, right? Without that, my data warehouse should not or will not be able to store the data, because data warehouses are made to store only clean structured data, right? That is ETL. Okay. Now, this scenario, basically, this framework faced few challenges. Okay. So, whatever challenges, challenges of, let's say, traditional data warehouse architecture. Okay, what challenges it faced? The first and most important challenge was increased data volumes. Okay, data volume got increased and data variety also got increased. Right, data variety as in the structured. Right, data, some data was structured, some data was semi-structured, and some data was unstructured, right? So increased data volumes brought pressures on this ETL, right? Because you have any data to, for that data to go to data warehouses, you should perform ETL operation first, right? So and data warehouses also were, more costlier as compared to data lakes, right? So that is the reason the first challenge it faced is increased data volumes, and data volume got increased with the rise of internet, with the rise of multiple, devices. Now you can see in today's era, right? we have huge amount of data. Every organization has got huge amount of data. Okay, and now we all know that data warehouse we just have seen used to receive the data from ETL operations, right? So this what happened? It huge time. It took huge time to perform ETL operations and load the data to data warehouse, right? So it brought kind of, let's say, pressure or load on engineers, the ETL developers, we can say, to clean the data, perform ETL operations, and then load it to data warehouse, right? Then the next challenge it faced is, let's say, traditional data warehouses faced the scalability issue, right? Scalability. So on premise, traditional data warehouses were on premise, right? So on premise means what? Let's say I have one organization, right? My organization is storing the servers for let's say it has its own servers, right? So if data volume is going on increasing, company has to increase their servers, right? So scalability was not that easy. What we see in today's world, what we have using cloud, that time company had to take care of all the infrastructure, all the admin operations, right? Everything company had to take care for on-premise data warehouses. Okay, so the important challenges faced was scalability. It was very difficult to scale up, right? It was, let's say, it was difficult to scale up and down also. Scale up and scale down. I mean to say, let's say today you have, let's say, um, 10 GB requirement, right? 10 GB requirement. I'm giving you a small example, right? And you need, let's say, uh, f- two servers for that. Okay, one server, two server. Okay, one server, two server. Okay, company has made the arrangement of those. Let's say 5 GB, right? Now, tomorrow your requirement has gone up to, let's say, 12 GB, right? You will need to bring in third server for this 2 GB, right? For this 2 GB. Now, this server has capacity of 5 GB, but you are only storing 2 GB here because your requirement is of only 12 GB. Okay. So for 3 GB, your company is paying, right? Company is already started taking care of this 5 GB server. Okay. I'm just giving you a rough, simple example, right? Now, let's say the requirement has gone down to 8 GB, right? 8 GB, for example. Now, this server, your company has to keep, empty. There is no way they cannot give it back. Okay, if they give back, again there is some cost involved, right? They have to scale up. So, for scaling up and scaling down, right? It was an issue for both, right? That is the reason uh, the traditional data warehouses face scalability issue, right? The next and important thing is traditional traditional data warehouses used proprietary proprietary file formats. Okay, used proprietary file formats. Now, what are proprietary file formats? Proprietary file formats is like, these are file formats owned and controlled by particular company or particular organization, right? So it means to use that file format, it usually will require a specific software or hardware from that company. Okay, so it is like vendor lock-in issue, right? If you want to use that proprietary file format, right, which is owned by some another organization or company, right, you will need that setup. Okay, so there were few advantages also for proprietary file format, and there were few disadvantages as well. So advantages were like, basically it had got good advanced features, right? the performance was optimized, but again the accessibility was limited. Okay. um, let's say only few licenses you are getting. Okay, so it had got licensing cost also. To use the file formats, you have to paid for the subscription. Okay, and let's say if that company stops supporting for that file format, let's say some proprietary file format, right? Okay, the organization A is supporting some proprietary file format, right? If they stop supporting that, then you have to do changes. I mean, you would imagine what level of changes in your code, right, in your data you have to do. Okay, so that was the main disadvantage, one of the main disadvantages of data warehouses. Okay, and again, there are many things like, if you wanted to share, right, let's say there is some file format. Okay, a file format is there. For example, there is some file format. Okay, a file format, a file format, right? You want that format to share with, let's say, b organization. For example, let's say you want to share it with Ganesh, for example. So basically Ganesh also will need to have all that setup in place. Okay, whatever setup you have done, Ganesh should have all that setup. Okay, then and then only Ganesh will be able to access this data, right? So this sharing also was very limited. Okay, and that was the reason, this was one of the important challenges that traditional data warehouses faced. Okay, they were using proprietary file formats. Okay, the next was, you all know, the high storage cost. Storage cost was high. Okay, because all the data that was coming in, right, all the data you have to do ETL on that data and store in data warehouses. Okay, so storage cost was really on higher side. Okay, and that is the reason it had, let's say, limited support for advanced analytics. Okay, if you want to do some advanced analytics on your data, your team was completely busy in ETL operations, right? You have storage limitations also, right? So it is very difficult and very costly to do advanced analytics on the data, right? Now all these issues, now I have already told you, see, if you are facing some challenges, right, if system A is facing some challenges, it will give birth to system B, right? All the challenges gave rise to data lakes, right? Data lakes. Now data lakes, we all know, the it has indefinite storage things, right? It can scale on a huge amount. Okay, and it can store structured, semi-structured and unstructured data, right? So basically all the limitations, okay, of data warehouses gave rise to data lake. Okay, now the first advantage of data lake is data lakes used to store all the data varieties, all the data varieties, I mean to say, structured, semi structured, unstructured, all the data you could store in data lakes. And data lakes used open, okay, open source file formats, open source file formats. So the file formats, like, let's say, parquet, right? Parquet, CSV, Avro, ORC, right? I will introduce you to all the file formats, okay, going ahead. But data lakes started using open file format. So these file formats were easy to share. Okay, the first and most important thing, they are good optimized. Okay, and there is nothing like vendor lock-in for these file formats. Okay, so that made data lakes very popular. Okay, and data lakes data lakes supported AI, ML, okay, workloads by by providing access to both raw and, let's say, transform data, raw and transformed data. So in data lake, you can store raw data also and transform data also. But data lake had few disadvantages, right? What were the disadvantages? The first thing is data lakes could not support ACID operations, right? I mean, if you have to do some insert, if you have to do some update, if you have to do some deletes, that was not supported by data lakes. Okay. Now, data lakes were um, not supporting the business intelligence reporting also, right? So what companies did basically, data lake is what, right? I told you this first thing, right? In data lake, you can dump all the data. Okay. So for example, now you have this data lake where you are dumping all your data. Okay. Let's say now you are cleaning this data. Okay. You are dumping all the data and based on your need, you are cleaning it. You are doing ELT. ELT is what? Extract, load, and transform. Whatever data you are needing, okay, you are just extracting from data lake and putting it to data warehouse, right? But the thing was now data warehouses were costly, right? So by doing the ELT also, you can keep the clean and raw data at same place, right? But the thing was, data lakes were not supporting the BI, the reporting use cases basically. So what companies had to do, they had to store subset of data. Okay, let's say in data lake I have 100 GB of data. Okay, what I have done, I have cleaned some data. Okay, and that, I mean, whatever data I am needing, right? And that data size has gone up now to 140 GB, right? Now, but there are some reporting use cases that companies has to handle. So what they have done, let's say that use case is needing, let's say, some 50 GB of data. Okay, not 50 GB, for example, the 40 GB of data that we have cleaned. Okay, so what happened, this resulted into a complex architecture. Okay, it added many tools along with data lake, right, along with this ELT operations. Okay, it added data warehouses also, and that increased cost. Okay, so we will understand what are the challenges that were faced by data lake architecture. The first thing we have seen is they did not support the ACID transactions. ACID as in, there was no support for inserts, no support for updates, no support for deletes. Okay, and if developers wanted to do that, they had to, like, partition the file and they had to rewrite the entire partition. Okay, so it was code heavy, it was time consuming, right? Now the second disadvantage was rollback also was difficult. Okay, if there is some data that you are writing to data lake, right, as it is not supporting ACID, okay, the rollback was difficult. Okay, and it is very difficult to recover from failures. Okay, I'll explain you the ACID in next video. You will understand how important ACID transactions are to recover from failure. Okay, to do inserts, updates, and delete, and to recover from inserts, updates, and delete failures. Okay, the next disadvantage was data lakes lacked support for, as I told you, BI workloads. Okay, business intelligence workload. Okay, data governance. Okay, it lacked support for data governance as well. Okay, these were the disadvantages the data lake architecture was facing. Okay, and for data lake, the batch and stream processing was separate. Okay, if you want to do batch processing and stream processing using data lake, you have to do it separately. Okay, so in a nutshell, what happened, the the data warehouse architecture excelled. Okay, in BI workloads, okay, but lack support for streaming, right? Data science, data science, because the full data, it was very hard to make full data available in data warehouses, okay, and ML, okay, but data lakes excelled excelled for data science, and ML workloads, and lacked support for BI, right? Business intelligence reports. And to bring the intermediate solution, what companies did, as I told you, they created a new, let's say, they just copied the required data to data warehouses. So that created a complex architecture, and that increased cost also. Okay. Now, because of all these challenges, okay, what happened? We can see we are needing all the, I would say, properties from data warehouse also and data lakes also, right? So this gave rise to data lakehouse. Okay, this gave rise to data warehouse. Now, what used to happen in data warehouse, I think I have already told you here in the start. All the data, all the data we are dumping to data lake, right? So all the raw data was stored in data lake, right? Because data lakes are cheap storage, okay. And now, if you see, you don't have to do ETL operations right away, right? As soon as you are receiving data, you don't have to do that, right? You have time to do that ETL operation, okay, because data is present in data lakes, okay. Without any transformation, you can store raw data in data lakes, okay. This option increased the ingestion time, right, and allowed more flexibility for transformations, okay. And the cloud data lakes, let's say, we have, let's say, for AWS, Amazon S3, right? Amazon S3, right? For this one, Azure cloud, we have AWS Gen 2, right? For Google cloud, we have GCP buckets, right? All these cloud based storages were object stores, and they are very cheap. They're very cheap storages, right? So it given a lot of flexibility, okay. And we, as we all know, data lakehouse data lakehouse best combines features of best features of data warehouse and data lakes. So one system one system was used to support AI, ML, BI, and data science workloads, right? You don't have to build a new system, right? In one system, in same data lakehouse system, you will be able to support AI, ML, BI, and data science workloads, okay. So basically, data lakehouse, it is providing a scalable storage and processing capabilities for all modern organization, that like whatever organizations, they want to avoid isolated systems, okay, for processing different workloads. Let's say we are looking to um, give support for all the workloads in one system. So that system is data lakehouse, okay. So data lakehouse helps data lakehouse helps to to establish a single source of truth, a single source of truth. And this sentence, a single source of truth, you will understand much deeper when we go ahead, right? Because all the data is stored at one place, right? Your business users are coming, they are, they are looking for whatever data they want. Your AI engineer, ML engineer, data science engineer, whoever data engineer is coming, the data is stored at one place, okay. So this established a single source of truth, okay. And it eliminated eliminated redundant cost, right? So you don't need to create multiple systems, it is one system. So cost saving was also achieved. Okay. And it ensured and it ensured data freshness. Data freshness as in whatever new data you are getting, you dump it to data lake, right? Based on your needs, you do your ETL operations, right? You schedule your ETL operations later on, right? And data lakes, basically I told you data lakes was data lakes is giving the asset guarantees, right? So data lakes are providing asset guarantees the file format using the file format called as delta, right? Delta file format, I'll explain you what is delta file format. Just as of now, keep in mind, this is like, what is delta? Delta is basically a cheap storage. Okay. For example, underlying you have data lake, right? On top of that you have, let's say, acid and data governance. Okay. So underlying data is stored in data lake only, right? But this data lake is made to support ACID and data governance use. ACID and data governance for that data, right? So this entire system, right? We call it as data lakehouse. Okay, that is the beauty. So it achieved that using delta file format. What is delta file format? We are going to understand that in details. Okay. And data governance was achieved using unity catalog. Okay. Unity catalog is like centralized open source tool by databricks, okay, which is used for achieved, okay, which is used for data governance and data management. Okay. And most importantly, data lakehouse data lakehouse supported batch and streaming workloads, right? So data lake houses supported both batch and streaming workloads. So it eliminated the need of the complex architecture that was needed, right? When we had, like, we were doing, for example, I told you some subset of data companies were copying to data warehouses from data lake architecture, right? So it removed the need for that. It was not no more needed, right? So now, in the end, we will see the in in total, what are the advantages of data lakehouse? Whatever advantages of data lakehouse architecture, right? The first advantage is handling all types of data, and this, it has taken from which data lake, right? The storage and scalability, right? So storage and scalability. Storage was very cheap. We just have understood the cloud based storages, right? They are object storages and they are very cheap and very easy to scale. Your demand that is going up or down, that is fine. It is very easy to scale and scale down, right? Then it was using open source file formats, right? It was using open source file format like Parquet, CSV, Avro, ORC, right? uh, then removed the dependency on multiple systems. Everything was happening in one system, right? You don't need to prepare separate data warehouse or something like that. Everything is in data lakehouse itself, right? Then it started supporting acid and version history, right? It is very important, version history. Whatever data that is coming in, whatever changes you are doing to the data, right, that is getting stored in version history, and we are going to look at it, all these things in detail going ahead. But just keep in mind it is supporting the ACID guarantees and version history. Okay. And the most important thing is simple architecture. Simple architecture, right? Simple architecture. Okay. Why simple? It is because let's say you have 10 sources of data. You have, let's say, I'll now put some 4 5 sources. Okay. Let's say 1 2 3 4 5. Okay. These are sources. Let's say this is SQL server where some transactional data is getting generated. This is, let's say, some mainframe application, right? This one, let's say, some backend files are there. Okay. And here, let's say, some, let's say, cloud based storage. Okay. Some data is there in cloud based storage. All this data you can bring into your data lake, right? You can ingest, we call it data ingestion, right? You ingest all this data to your data lake. Okay. So all the data is going to be, just a second. Okay. All the data is going to be stored at one place. We make it like this. Okay. It is going to be stored here only. From backend also, whatever data you are getting, it will be stored here. From cloud based storage, any whatever data you are getting, you are going to store all the data to data lake. Okay. Now here data lake house we can call it, right? Data lake house. Now whatever ETL you are doing, for example, you have some ETL that you are doing. Okay. Data lake house, let's say it has few compartments, for example. Okay. You have here raw data. All raw data is here. Okay. Now you have to, let's say, uh, use some data for, let's say, reporting, right? Reporting. Okay. Now let's say you have to use some data for, let's say, ML, right? So all this data, it is present within data lake house itself, right? So this data, let's say this raw data is coming to your some ETL operation. Okay. Some transformation, for example, some transformations you are writing. Okay. And this data through, again, after it is transformed, you are putting again to same lake house, right? Or after these transformations, you are putting it for some ML workloads. Let's say your 10 users have to use this data, or your then 100 users have to use this reporting data. So it eliminated the need of complex architecture. It is not no more needed. I mean, it's the only one system which is handling everything, right? So that is the reason, if you see, all the data is getting stored in data lakehouse. Okay. And through all the transformations, okay, you will be using the data for different use cases. Okay. So that is the, I think, revolution, or we can say that is revolution in data engineering word that has happened. Okay. And um, it gave rise to data lakehouse architecture. Now this was just a theoretical idea. In next few sessions, we will, before we create the databricks service and before we see the databricks UI, I'm going to make sure that all these concepts are clear. I'm telling all these things beforehand, so that when we enter into databricks, you will not be confused. What is data lake house, right? What is data lake? What is data warehouse, right? What is unity catalog? What are ACID guarantees? Okay. Everything we are going to learn in this initial, I think, 4 to 5 sessions. Okay. So this was about data lake house. I hope I could clear your understanding. We have seen in the start, we have data warehouses, right? We have seen the advantages of data warehouses, then disadvantages. Those disadvantages lead to creation of data lake architecture, right? Data lake had a few disadvantages, right? Few cons of it led to creation of data lake house, and now data lake house are, let's say, I would say, leading with pride. Okay. All the changes, all the I mean, say, optimizations, okay, dates are coming to data lake house, and It is proving to be very useful in current, not only data engineering world, but in Gen AI or any other AI use cases also. Right? Fine. I think that's all for this video. I know videos are getting a little longer, but I have already said first 4 to 5 videos, they are going to be a conceptual, theoretical. Okay, so sit back, relax, and watch them. Okay, if you want to take a note, do take notes because that definitely makes to sharpen your concepts. Okay, fine. That's all for this video. If you feel this is useful for YouTube, do like, share, subscribe, comment, and share. Okay, for Udemy, right? To give me a review so that other peoples also will get advantage from this one. Fine. That's all. I'll see you in the next video.